this video we are going to learn about the octet rule and how to construct dot and cross diagrams to show the covalent bonding in hydrogen, oxygen and nitrogen. As seen in the video how atoms bond, when two hydrogen atoms bond, the shells overlap, and because each atom only has one electron to share, there are two electrons being shared over two shells. These are represented by a dot and a cross. Which noble gas does this correspond with? Pause the video and continue when ready. The answer is helium, which has two electrons in its outer shell. As a result of electron sharing, each hydrogen atom now also has two electrons in its outer shell. In the next example, we are going to consider oxygen. It's in group 6. Therefore, how many electrons does each oxygen atom need in its outer shell to fulfill a noble gas structure? Remember, oxygen has 8 electrons in total, so we would need to fill the second shell. Pause the video and continue when you're ready. The answer is that each oxygen atom needs 2 more electrons before fulfilling a noble gas structure. This is also called the octet rule. In this example, the octet rule is fulfilled because each oxygen atom shares 2 electrons in the outer shell, forming an O2 molecule. If you count the number of electrons in each shell, you should notice that each shell has 8 electrons shared over 2 shells, shown by the dots for one oxygen atom and crosses for the other, which is the ideal. Whenever you draw a dot and cross diagram, wherever possible, you should ensure that A, the electrons are equally spaced, and B, that they are paired. The fact there are 2 shared pairs of electrons in the middle, where the shells overlap, means that the oxygen molecule, O2, has 2 covalent bonds connecting each oxygen atom. This is called a double bond. Each of the nitrogen atoms has 5 electrons in their outer shells. How many electrons, therefore, do you think each will need to share to fulfill the octet rule? Pause the video and continue when ready. If you said that 3 electrons are available to form a shared pair, you'd be correct. You should see that there are 3 shared pairs of electrons in the overlap of the shells. This is called a triple bond. You should also notice that this example fulfills the octet rule.